Okay, we have discussed up to the flowcharts, and we just
So actually we finished the SDLC, like system
yeah,
development life cycle.
yeah,
Only that.
yeah. Up to this, we have finished, right? Up to the flowcharts.
We didn't do flow charts as I remember. Um,
We didn't start this part.
no,
Only this
no,
day.
no.
All right. Okay. 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 Doesn't matter. Right. Okay. Right. Actually, in the SDLC, this is coming under the system design. Right. We have like under the SDLC, we have discussed these things. Then actually, then we need to discuss in detail. Right. So the problem definition or the requirement analysis space we have identified, and we have even we saw the questions, how the questions are coming from these requirements. So the functional requirements, non-functional requirements, how things are coming from that side, we have just decided. And then, so system designing is the next phase. The next important thing is system design. System designing is the phase where we are using the diagrammatic tools, and also we are using various techniques, structured and also object-oriented structured techniques. We are using this system in system designing phase. System designing is basically kind of, so when we need to construct a house, we need to plan, right? ගෙදරක් හදන්න ඕන නම් අපි ඊට කලින් plan එකක් සැලැස්මක් හදනවා. මේ සැලැස්ම තමයි අපි ඊළඟට plan ඇත්ත එක බවට ගෙනියන්නේ. සැලැස්ම තමයි අපි ඇත්තටම ගොඩනගන්නේ. So this is like that. So before we create the system, we create the plan. So we are using different tools, flowcharts, pseudocodes, unified modeling language diagrams. We will explain this one by one. What these flowcharts, what are the pseudocodes, what are these UML diagrams. Anyway, these are also parts of the plan. Plan again, this is also a part of the plan. So we are going to discuss about this plan in the system system designing phase. Designing system designing place, we are going to use this plan. Actually, this flow chart is kind of set of symbols. It is actually a set of symbols. And why we are using flow charts? This is most of the places, at least almost all the places where software engineering come to the playground, we are using flow charts. Flow chart. So the thing is, this is to limit the complexity. Limited set of symbols, less complex, easy to explain without much words. Vachana godak dagena make explain karnata වැඩිය flow charts වලින් කරන එක lazy. Flow charts වලින් අපිට මේක explain කරන එක මාර පහසුයි. Okay, so එතකොට ඒ හින්දා තමයි අපි flow chart use කරන්නේ. This is actually a set of symbols. So these are the symbols that we are using in the flow chart. එතකොට මෙන්න මේ ටික මතක තියාගන්න. You can write down as symbols also. Please write down flow chart. Flowchart is a symbolic representation. Right? Flowchart is a symbolic representation. So rather than using the natural language, we can use flowchart to explain a process clearly. Okay, write down the heading flowcharts. Under that, flowchart කියලා ලියා ගන්න. ඒක යටතේ ලියා ගන්න පුළුවන්. We can explain the plan using limited set of symbols. That is to reduce the ambiguity. That is to reduce the ambiguity in programming language. So in addition to that, we can write flowchart is a symbolic representation of the system plan. It is symbolic representation of system plan. So please write down this part. Okay, before writing these questions, please write down. Then after writing this part, please draw the flowchart symbols. So these are the flowchart symbols. මේවා තමයි අපිට flowchart symbol විදිහට යොදා ගන්න පුළුවන්. So let's I will explain that, right? After that I will explain how these flowchart symbols are working. I'll explain one by one. But before that, please write down, because so we need a formal start before we begin. Then please write down the flowchart symbols. This one. There are 6 symbols. These 6 symbols are, what are these 6 symbols? Start, stop, that is ellipse. Process, which is rectangle. Parallelogram, සමාන්තරාශ්‍රයක් තියෙන්නේ, that is input output. Decision using diamond. Connector using a circle, and data flow using arrows. So very simple. ඔච්චරයි symbol තියෙන්නේ. So each and every exam you will get a question. හැම exam එකකම අනිවාර්යෙන්ම MCQ වල ඒ වගේම essay part එකේ ඔයාලට question එකක් එනවාමයි මේකේ. එනවාමයි. අනිවාර්යයෙන්. මේ පාරත් ඒ වගේ නේද question paper එක බැලුවා. Okay, finish. Finish. No, okay. හරි පුතේ, හරි. Okay. So flowchart symbols. Flowchart symbols, start, stop, process, ක්‍රියාවලිය, start ආරම්භය, ක්‍රියාවලිය. Input output is denoted by this. Input output is denoted by this. Decision, තීරණ, connector, and data flow. හරි. අපිට ගන්න පුළුවන් in programming we are going to recognize 3 things when we are doing programming. So these things are fundamental to any programming language. හැම programming language එකකටම මේක basically අපි ඉගෙන ගන්න දෙයක්. Either we are using coding, programming, robotics, whatever we learn. So this is very important, right? So one thing is sequence. එකක් තමයි sequence, අනුපිළිවෙල. So in programming there are things happening in a sequential order. It is like this. Okay, we write the first line, go to the next line, write second line, go to the next line. Likewise, when we are writing a letter, we go in a sequential order, one by one after another, in a sequential order, one by one after another, in a sequential order. That is called sequence. Okay, so let me show an example first. This is not there for your A-level examination, but just to get an idea, right? A-level exam එකට මේක නැහැ නිකම් මම ඔයාලට මේ අදහසකට විතරයි මේක කරන්නේ. Just to give you an idea. This is normally used for kids. චූටි ළමයින්ට තමයි මේ programming වලට මේක දෙන්නේ. හැබැයි මම ඔයාලට නිකන් පෙන්නන්නම් මේක අර අදහසක් ගන්න හරි හොඳයි. Let's think that you need to add few numbers. Let's see, I think you need to add few numbers. So you can start. Right, you can start. When flag click, you can start. Okay. So normally how to get the numbers here. So these are actually code blocks. You can ask from the user, enter a number. Enter a number. No need to understand the programming language. Right? Programming language එක ඒවා තේරුම් ගන්න try කරන්න එපා. මේ ක්‍රමය විතරක් තේරුම් ගන්න. I just need to put the instructions one after another. Then I need to get the answer and assign it to some variable. Variable is a memory location. I'm going to assign it to number 1, n1. Okay, set n1 to this answer. Likewise, if I need 3 numbers, I can duplicate and get this 3 times. So I can assign that to 3 variables, n2 and n3. So here n2 is the second, n3 is the third. So let's think that I need to find the total. So total is none other than adding these two. Set total to, you can add these numbers. You can add these numbers together. What are these numbers? That is n1, n2 and n3. n1, n2, n3, you can add it. n1, n2, n3, this thing you can add. Then you will get the total. Finally, let's think that you are going to display this total back to the user. Say total is this variable. Say total. Okay, this is example for sequence. Make example like a sequence. See, things are happening one after another. Enter a number, first number enter a number, second number, enter a number, it will add the numbers and show the total. Right? This is sequence, right? Ayat balan. First, second, third, add the numbers, display the total. This is called sequence. Easy. Right? In a road, you are going one direction, step by step. That is called sequence. In programming, this is very common control structure. The second one is called selection. Selection, there is a condition. Okay, let's think something like this. I'm going to find the average. I have another variable, average. So let's assign this average. Average is equal to total divided by 3 now. I can divide the total by 3 and assign that to the average. Total 3 බෙදලා අපි average එක ගමු. Total 3 බෙදලා average එක ගමු. දැන් මට මේකෙන් decision එකක් ගන්න ඕනේ. Average එක 50ට වැඩි ළමයි pass කරන්න ඕනේ. හරි. Average එක 50ට අඩු ළමයි fail කරන්න ඕනේ. If average greater than 50 pass. If average less than 50 fail. Can we pass and fail student one time? එකම වෙලාවට student ව pass උත් කරලා fail උත් කරන්න පුළුවන්ද? Can we do like that practically? Hope you are listening to me, right? මම කියන දේ අහගෙන නේද ඉන්නේ? Can we pass a student and same time can we fail the same student? Hello? පුළුවන්ද එහෙම එකම වෙලාවේ student ව pass උත් කරලා fail උත් කරන්න පුළුවන්ද? Can we pass the student and fail the student same time? Halhara, can you hear me?
Now I can hear, sir. Small network problem, sorry.
All right, okay. Can we pass a student and can we fail the student same time? එකම වෙලාවට student ව pass උත් කරලා fail උත් කරන්න පුළුවන්ද?
No.
No. Either we can pass the student or we can fail the student. හරිද? එක්ක student ව pass කරන්න වෙනවා නැත්නම් student ව fail කරන්න වෙනවා. දෙකෙන් එකක් නේ. ඒ වගේ තමයි මේ selection කියන එක. In selection you have to decide whether to pass or fail. right? ඒක ඔයාලා decide කරන්න ඕන. pass කරනවද fail කරනවද? pass වෙනවද fail වෙනවද කියන එක. That is one decision. You can use this and do this. If හරි අපි ගන්නකො මෙහෙම. If average greater than 50. හරි, if average greater than 50, then you can say pass. Say you have passed. pass වුණා. And if average less than, greater than 50 නෙවෙයි නම්, you can say, ඒ කියන්නේ 50 හෝ අඩුයි නම්, you have failed. Well, this is something like that. This is called selection. එතකොට sequence තියෙනවා අනිත් පැත්තට selection. Selection කියලා කියන්නේ අපිට තීරණයක් ගන්න වෙනවා. අපි junction එකට ඇවිල්ලා ඉන්නවා නම් අපිට තීරණයක් ගන්න වෙනවා either to turn left or right. වමටද හැරෙන්නේ දකුණටද හැරෙන්නේ කියලා තීරණයක් ගන්න වෙනවා. right? වමටද යන්නේ දකුණටද යන්නේ කියලා අපිට තීරණයක් ගන්න වෙනවා. ඉතින් අපි junction එකේ ඉන්නවා නම් වමටයි දකුණටයි එකවර යන්න බෑ.
Yeah.
Right? So that is what the sequence selection is. Okay. The next is repetition. Right? Next is repetition, repeating. Same thing, if same one is repeated and repeated, we call that repetition. Okay, let me give an example for that as well. එකකට මම example එකක් දෙන්න. Okay, let's have another control. I'm going to set another event when space key is pressed. හරි, අපි මෙහෙම එකක් හිතමු. Space key එක press කරාම I need to rotate this cat. Okay, I need to rotate this cat 10 times. Repeat 10 times. I need to rotate. In each time, I need to rotate 15 degrees. Okay, now when I press the space key, you can see it's repeating, it's rotating 15 degrees. And if I tell this, okay, I need to repeat 30 times. When I press the space, you can see it's rotating 30 times. So repeatedly, same set of instructions are executed again and again. We call that repetition. So now we have learned all three control structures. What are they? Sequence, selection, repetition. Sequence is where the instructions are executed one after another. Selection is where the instruction flow is based on a condition. Repetition is where instruction flow is repeated based on a condition. That's it. So can we write down this? Okay, shall we write down this?
Okay, sir.
Also the question, right? Also the question. Out. Let's try to solve a question related to this is related to sequence. No, pseudocode. Pseudocode is like it is nothing other than the structured code. So you can see the text inside this is written again in an order. We call that pseudocode. Pseudocode is not a working code, but it is a working code template. It is English. It is not a working code, but it is just structured English. Just structured English. You write down that as well. And it is not a working code. Remember that too. It is not a working code. වැඩ කරන code එකක් නෙවෙයි. Just to, right? It is just to indicate how this works. Same text in the flowchart can be used to write pseudocode. That is also a design tool. Okay, next. I will show you another question. This is related to the second control structure, selection. Okay, I have added 3 questions here. First question I will help. The second question and third question I will let you do. Okay, the first question. Using if else, all these decisions. Here, the instruction flow is selected based on a condition. Instruction flow is selected based on a condition. Instruction flow is based on select on a condition. Right, in code we are using if else. Right. For an example, think about this. Enter two numbers and find the maximum number. Enter two numbers and find the maximum number. So how can we do that? We can first input two numbers as usual, similar to the previous example. Then we have to decide, we have to compare them. If n1 is greater than n2, n1 is the first number, n2 is the second number. If n1 is greater than, if it is yes, n1 is the largest. If it is no, n2 is the largest. So based on that condition, we can select which is the large number. And then we can combine the flows and end this program. Combine the flow and end this program. Okay, now first write down this highlighted, non-highlighted things in English medium. Then what you need to do, then try to answer question 2 and question 3. Question 2 and question 3. You can send the answers in WhatsApp after drawing. You can draw it in your book, send it to the WhatsApp. Let's see this. First, you are comparing whether N1 and N2. Among them, what is the minimum? So if N1 is larger, then definitely N2 is smaller, right? So if N2 is smaller, if N1 is larger, yes. If N1 is larger, means N2 is the smallest. So then you are comparing N2 and N3. Then still that if N2 is larger, then N3 is smaller. So you have to display N3 there. The other way, yes, this side, if it is yes, yes, it's confusing, right? So if it is no yes, continue the same no yes in the structure, then
Okay.
otherwise it's confusing. But anyway, this is okay. If N2 and N3, if N2 is the largest, N3 is the minimum. If not, N2 is the minimum. Here also, if you are checking N1, N2, and here, if N1 is not largest, means N1 can be the small number. Then you are checking N1 and N3. And again, after that, if N1 is largest, you are printing, if N1 is not largest, you are printing N1, if not N3. Okay, then you are merging this. Okay. No harm. But I think we can do something like this. Maybe we can compare two things together. So it's like this. You start, think about this as well. You start as usual. Then you are checking, getting these inputs. With the parallelogram, you can get the inputs N1, N2, N3. After getting the inputs, you need to mention the arrows, right? After getting the inputs, you have to check whether, okay, you are asked to print the minimum of those three, minimum from those three. Then you can do something like this to find the minimum. You can check, take a one number, maybe N1, and you can check whether is it less than N2, and same time N1 less than N3. If it is less than both N2 and N3, so if it is yes, definitely N1 is the smallest number. No doubt about that. You can print N1 or display N1, no doubt about that, because it is less than N2 and N3 both. Your one problem is solved there. If N1 is the smallest, that will be kept, that will be printed. You are done. If not, the problem comes if it is not. If it is not, no, then you have to, like, if N1 is not the smallest, if N1 is smallest, it will be picked. If it is not the smallest, so either N2 or N3 is the small. You can again compare these two. This time what you need to compare? You need to compare N1 and N, because N2 and N3 are divided. N1 is already. So if it is N1 is less than, you will already pick. But if it is not, no. N1 is not the least number, then you are checking N2 and N3. So this check is enough. Why? This check is enough. Why? If N2 is less than, if this is yes, then no doubt about that, you have to print N2. Because if N2 is less, that is the minimum, right? No need to worry, that is the minimum. Display N2. And if not, if it is not, display entry. Finally, take all together and stop the program. So this way you need only 2 selections. This way you need only 2 selections. It's not 3 selections. You need only 2 selections. That's it. Okay, understood? Hello?
Yes.
Did you understand? Yeah.
Yep.
Okay.
So
yeah.
So basically, we can use in a decision box. We can say two logic. Again, අපිට decision
two or more, any 1 or 2 or 3 or 4 or
comparison දෙයක් તો එහෙම දාන්න පුළුවන් නේ ප්‍රශ්න නැහැ.
Yeah, that is not problem. You have to make it shorter anyhow. Okay. Otherwise, a lot of decisions, right? Otherwise, because if you can remove one from N1, if you can remove from the first instance, it is easy. Because then you have to consider about N2 entry only. Okay. Finish writing this?
Yeah.
Okay. Then the odd even one is, it is easy. Odd even one is basically you can check the divisibility. If the number is divisible by here, this is what I said. You are checking N1, N2 both, and then if it is yes, display N1. Otherwise, you have to check for this N2 entry, and based on that, you can select that. So the odd evenness, you can do this with the modulus operation. You can divide and see whether the remainder is 1. So if after dividing by 2, if remainder, mod means divide that, find the remainder. After dividing by 2, if remainder is 1, that is odd number. After dividing by 2, if remainder is 0, it is even number. So that is how simple that is. It's very easy. Finding odd even. This is for the third question. Okay.
Yes, sir.
Okay, please write down this 2. Please draw this 2. Okay, let's try to learn the repetition 2. Let's try to learn the repetition 2. That is our third control structure. Okay?
Yes, sir.
That is our third control structure, repetition. Okay. Here, please see this flow chart. Right. In this flow chart, we need to print even numbers from 1 to 10. Even numbers. Even numbers are 2, 4, 6, 8, and 10. So, what I have done here, I have started with this start symbol and start with 2. Then I'm checking whether it is less than 10 because I need to print numbers from 1 to 10. I'm checking whether it is less than 10. So 2 is less than 10. Yes, 2 is less than 10. So display 2 and add 2 to 2. 2 plus 2 is 4. You go back. The speciality of repetition is it's supporting this movement back to the beginning somewhere. It's created in a loop. Loop means this arrow forms a cycle. You can see these arrows, it forms a cycle. Right, then you can see this continuous loop. Continuous loops, these arrows are falling down, then coming back and coming to the previous, again falling down. Likewise, it forms a cycle. But see that even though it looks like a cycle here, it's not actually a cycle because these arrows are not coming back here. These arrows going like this, but it's not never coming back. Here also arrows going like this. Even it looks like a circle, it is not. Right, it is not. Here also it looks like a circle, but it is not. Or arrows are always falling down, never coming back. It's like this here, this way only this way. No way to come back. So these are selections, but repetition, same symbol set. But the thing is, you can see these arrows are forming a cycle. Arrows are forming a cycle. Arrows මෙහෙම වක්‍රාකාරව ගිහිල්ලා මෙතනට එනවා. Arrows are forming a cycle. That is what the repetition is. Okay. Right, that's it. And so here starting from 2, 2 less than 10, print 2 at 2, now 4, 4 less than 10, print 4 at 2, now 6, less than 10, print 6 at 2, now 8, 8 less than 10, print 8 at 2, now 10, 10 is not less than but equal to 10. So print 10 at 2, now 12, 12 is not less than or equal, so come back and stop. So this is called a loop. This is called a loop. You can write down this quickly. Right, I will give this as a homework. Just try these things. Okay, write down this question and try to do this as a homework. Flowchart and write pseudocode to print odd numbers from 1 to 10, square numbers from 1 to 100, and triangular numbers from 1 to 100. Odd numbers from 1 to 10, square numbers from 1 to 100, and triangular numbers from 1 to 100. Please try this as a homework. Okay. So if you complete, you can send the WhatsApp message to me. Right. Okay, finish writing.
I finished that pseudocode pseudocode thing, but I didn't do the question though.
Okay. No need to do the question. Write down the question and do it.
Okay. I wrote it.
Okay then. Right. Then I'll stop from here. So please try to answer these questions. Then next day we'll discuss the remaining part. Okay.
Okay.